So when you're solving an equation that involves a radical, remember you want to start by isolating the radical. So I'm going to subtract my 9x from both sides. So I'm going to subtract 9x here, and I'm going to subtract 9x over here. All right, so I'm going to just write this over here, sorry. So I'm going to get the square root of 54 minus 21x minus 2x squared, and that's going to equal, I'm just going to rearrange this a little bit. So I'm going to put the 7 first, and then I know 7x minus 9x is negative 2x. Okay, then the next thing we're going to do is, once you isolate the radical, remember if we're trying to get, we have the radical isolated, now we want to try to get rid of that radical. So I'm going to do the opposite, which is squaring, but if I square one side, I have to square the other. Now just be careful. Remember that if I square that binomial on the right side, what that really means is 7 minus 2x times 7 minus 2x. And any quantity that's squared means that thing multiplied by itself twice. Okay? All right, so on the left, our radical and our squared will cancel out. So I'm just left with 54 minus 21x minus 2x squared. Okay, now on the right I'm going to double distribute. So I'm going to do the 7 times 7, which is 49, and then the 7 times negative 2x, which is minus 14x. Then I'm going to distribute the negative 2x times the 7, which is another negative 14x, and then distribute the negative 2x times the negative 2x, which is positive 4x squared. Okay, now let's take a look at what we've got here, because we want to try to solve for x. So if we look here, my highest power on the left side is an x squared, and my highest power on the right side is an x squared. But this one's bigger, because that's a 4x squared, and this is a negative 2x squared. So what I think I'm going to try to do is get everything here on the left and bring it over to the right-hand side and set it equal to 0. So that way, I have a quadratic that will be set equal to 0, and I can either factor or do the quadratic formula. Okay, so I'm going to start by subtracting 54 and subtracting 54. Then I'm going to add 21x, and, well, I'm going to put the add 21x right here in the middle, because I see that these guys are like terms with that. Okay, probably not the best thing I should have done. Sorry, I should have added those negative 14x's together first. And then I'm going to add 2x squared over here. Okay, so everything on the left-hand side is going to cross out, right? So I'm going to get 0 equals. All right, what I'm going to do is not only, okay, never mind. I'm not going to do that. So 49 minus 54 will be a negative 5. Then just be a little careful here. So I have negative 14 and negative 14, so that's negative 28. But I have a positive 21. So again, negative 28 plus a 21x. Okay, and that's going to leave me with negative 7x. And then I've got plus 6x squared. Okay, I'd like to put that in standard form, so let me rearrange that. Highest power comes first, so that would be 6x squared, then minus 7x, and then minus 5, and then equals 0. Okay? Oop, let's make that look like 0. There we go. All right, so I have a quadratic because my highest power is squared, right? However, my lead coefficient is not a 1. It's a 6. So I'm going to try doing rainbow method. You also, by the way, could do quadratic formula if maybe factoring isn't your thing. But I'm going to do rainbow. So I'm going to figure out what multiplies here to negative 30 and what adds to negative 7. Okay, so remember when you're doing rainbow, you bring down the first term, you bring down the last term, again set this equal to 0, and then I figure out what multiplies to negative 30 that would add to negative 7. And that would be a negative 10x and a positive 3x. Then we're going to group and group. Okay, so my first group, I see that I have a common factor of 2x, and that's going to give me 3x minus 5. My next group, I don't have anything in common, so I'm just going to take out a 1, and I have 3x minus 5. So that gives me 2x plus 1 and 3x minus 5. Okay, let's do my little t-chart here. And I have 2x plus 1 equal to 0. Subtract 1 from both sides. So that's 2x equals negative 1. And then divide by 2. So x is equal to negative 1/2. All right, let's do the other side. So I have 3x minus 5 equals 0. I'm going to add 5 to both sides. So that gives me 3x equals 5. Divide 3 by both sides. And I have x equals 5/3. Now, once you get those two answers, remember that you have to take those two answers and you need to check them back in the original equation. And to make sure, in this case, so for example, let's say I take my solution of negative 1/2. I need to put negative 1/2 in for x here, and here, and here, get an answer, and then put the negative 1/2 in over here, get an answer, and see if the left and the right are equal. Now, we can do that easily in the calculator. So for example, take the negative 1/2 that you got and store it in as x in your calculator. So it should look like this. Okay, negative 1 over 2, hit your alpha y equals. Okay, negative 1 over 2, and hit your store button in the bottom left-hand corner, x, and then hit enter, and you'll get this negative 1/2. Then what I did was I typed in the left side of the equation, and it gives me 7/2. So what that's doing is that's taking that negative 1/2 that you stored in as x, and it's putting a negative 1/2 here, a negative 1/2 here, and a negative 1/2 there. And we're getting 7/2. And now look, I typed in the right side of the equal sign, and I also got 7/2. So this is how I know that the 0 of negative 1/2 checks. You'll do the same thing, I'm not going to show it, but you'll do the same thing for 5/3. It will also check. So your answer is x equals negative 1/2 and x equals 5/3. So just like we did in number 1, you need to isolate the radical for number 2 to solve for x. But in this case, we actually have 2 radicals. So kind of hard to isolate them when we've got 2 of them. So really, you can kind of take your pick and move one of them. It doesn't really matter which one you move, but just move one of them. So I'm going to move the radical x minus 3. So I'm just going to subtract radical x minus 3 from the left side, which will cancel that out. And I'm going to subtract radical x minus 3 on the right side. All right, so what that gives me is radical x plus 2 equals 5 minus radical x minus 3. So I have isolated one of the radicals. So just think about what we did with number 1. Once we isolated a radical, we squared both sides, right? So I square the left side so that the radical will cancel out. I'm going to square the right side as well. But just like in number 1, we have to be careful here. That's a binomial. So what that really means is, and let me write it down here, it means 5 minus the square root of x minus 3. It's a minus sign, times 5 minus the square root of x minus 3. So we're going to have to double distribute that. All right, so on the left, I just have x plus 2, right, because the square root canceled out. Now, let's double distribute. So I'm going to get 25. And then 5 times that negative radical x minus 3 is going to be minus 5 radical x minus 3. Then I'm going to double distribute here, and that will also give me minus 5 radical x minus 3. And lastly, I'm going to distribute those two. Well, I have two negatives, so that's going to make a positive. And radical x minus 3 times radical x minus 3 is just a plain old regular x minus 3. Okay, because remember, any radical times itself is just that thing underneath the radical. Now, you don't really necessarily need to have the parentheses here. I did it because it's a binomial. So this plus sign technically would distribute through, which won't change the signs here. But be careful, because sometimes this would be a minus sign, right? And remember, if you have a minus sign distributing through a binomial, that would change the sign of the x and the sign of the negative 3. But again, in this case, it doesn't. So I'll take it away in the next step, but just so we're clear on that. All right, so let's see if we can simplify a little bit here. So I have x plus 2 on the left, right, equals. All right, so I have 25 here, but all the way down here at the end, I also have a negative 3, right? So I can do 25 minus 3, which would give me 22. Then I've got these two radical thingies here, so I'm just going to add like terms. Well, I know negative 5 and negative 5 is negative 10. And then we just bring the radical x minus 3 down for the right. Okay? And then the last thing I have, and let's not forget that, is I still have this plus x here at the end. So I want to just write plus x. Okay? Well, let's see. What do we want to do now? Well, I know that if I subtract my x from both sides, right? Won't that cancel those guys out? Okay, so then I have 2 equals 22 minus 10 radical x minus 3. Now let's think about this for a little bit. I probably like to try to get that radical by itself, so let me try to get things isolated. So I'm actually going to move this 22 over by subtracting it. That will cross that out, and that's going to give me negative 20 equals negative 10 radical x minus 3. Again, I'm still trying to isolate that radical. So how about I start by getting rid of that negative 10 if I divide, which is going to give me 2 equals the square root of x minus 3. Then, if I want to get rid of the radical, remember, I will just square, because a square and a radical will cancel each other out. But what I do to one side, I have to do to the other. So just make sure that you square that 2 on the left as well. So that's going to be 4 equals x minus 3. And then let's add 3 to both sides. I'm just going to stick this up over here, sorry. And I get x equals 7. Now, if you go back and watch the video for the last part of number 1, you do need to check x equals 7 in your original equation and make sure that the left side will equal the right side. You can store 7 in as x and then type in the left side and see if you get 5, because if you get 5, if I plug in a 7 here and a 7 here, and I work all this out, and again, I can do that in the calculator, I should get 5. Now, if you forget how to do it in the calculator, go back and watch the end of example number 1. Watch the end part of that video and you'll see how to do that. So this is a multiple choice question, so I think the easiest thing to do is just plug in your answer choices. So what I started by doing was I looked at choice 1 and I saw that the first answer choice was a 3. So if you look at my calculator down here, okay, I just stored in my calculator 3 stores x and then I hit enter. So now all I'm going to do is I'm going to type in this left side of the equation into my calculator and see if I end up getting 3. If I do, I know that that's an answer choice. If I don't, then I know that it's not. So you can see now what I did was I typed in the left side of the equal sign, and you can clearly see that when I typed in this left side here, I got 3, which matches this right side of the equation. So I know that 3 is an answer, is a solution. So obviously I'm looking at choice 1, which has a 3 in it, and I'm looking at choice 2, which has a 3 in it. So I think I'd be better off also doing the same thing with 12. So you're going to put in 12 and store it as x. Same thing as what I did right here, except put a 12 here. Store it as x. Then type this in again and see if it gives you 3. I'm not going to show that. I'm figuring that you're big boys and girls and you could figure that out. Okay, so if you do that though, take my word for it, it works. So the answer for number 3 is choice 1. All right, so we're going to read this question together. So it says that the period of a pendulum, which is represented by the variable t, is the length of time it takes the pendulum to make one complete swing back and forth. So the pendulum of a clock. So they're talking about the period of that pendulum is represented by the variable t, and what it means is the length of time it takes for the pendulum to make one complete swing back and forth. Whoops. Okay, so they give you an equation. Let's just kind of skip that for a second here. I want to just jump down to the third sentence because it says if you want to build a grandfather clock with a pendulum that, here we go, swings back and forth twice every 5 seconds. So if it swings back and forth twice every 5 seconds, how long does it take the pendulum to swing back and forth once? So I'm going to repeat that again. So if it takes the pendulum, or I should say, if the pendulum can swing back and forth 2 times in 5 seconds, wouldn't that mean that the pendulum can swing back and forth once in half that time, which would be 2.5 seconds. So if the pendulum can swing back and forth once in 2.5 seconds, that means that t is represented by 2.5. Okay, does that make sense? So now I'm going to look at this equation that they gave me, which is t equals 2 pi times the square root of L divided by 32, and I know that t is 2.5. Okay? All right, now I skipped the second sentence, so let's just go back to that. So they gave you the formula right here. Okay, gives the period t for a pendulum of, here we go, length L in feet. So the length of the pendulum is L. So this L right here represents the length of the pendulum. And if you read the question, it says, how long would you make the pendulum? So the question's asking you to find L. So now if I go back to the rest of the equation that I didn't finish writing, again, I replaced my t right here with 2.5. Okay. And then now, if I write down the rest of the equation, I've got 2 pi times the square root of L over 32. So you can see that if I take this equation and I try to get the L by itself, I'll have my answer. So what would be the easiest thing to do first? wouldn't we try to isolate this radical? So if I want to isolate this radical, I want to try to get rid of this 2 pi and bring it to the other side over here. But these two guys right here are being multiplied right now. So I'm going to do the opposite, which would be to divide. So I'm going to divide both sides by 2 pi. Now I know this is going to look a little ugly, but that's okay. That's what we have calculators for. So then I have 2.5 divided by 2 pi equals the square root of L over 32. All right, I've isolated the radical. So now remember, if I want to get rid of the radical, I'm going to square both sides. Square the right, which will cancel out the radical. Square the left. Don't worry about the fact that it's ugly. That's why we have calculators. Okay? All right, so now I have that radical isolated. So I have 2.5, I have the radical isolated and I made it disappear by squaring both sides. So I have this quantity right here, that yuckiness, and it just equals L over 32. Well, technically, if I have L over 32, doesn't this mean that L is being divided by 32, right? Doesn't this mean division? So the way I can get rid of that 32 is by multiplying by 32. But what I do to the right, I'm just going to squeeze it in right here, I have to do to the left as well. And that will cancel out that 32. All right, so let me write that a little bit neater. So basically what I'm going to have is 2.5 divided by 2 pi. That quantity is squared. I'm going to put that in my calculator, and then I'm going to multiply that answer by 32. And that will give me my L. Okay? All right, let me squeeze that up over here. So when I do that, I get L equals 5.06605. Now, let's read the directions, because the directions say to the nearest tenth of a foot. So L equals 5.1, and don't forget your units. So that would be feet. Okay? L equals 5.1 feet. So when you look at this question, I think the easiest thing that we should probably start with is remember when we do PEMDAS, we always do what's inside the parentheses first. So I see that I have division here, and I also have the same base. I have an x and I have an x. So remember, when you have the same base and you have division, you subtract the exponents. So I'm going to keep the base, right? And then I'm going to subtract the exponents. So I'm going to do 2 minus 1/3. And you can do that in your calculator. You're going to end up getting 5/3. Okay, so let me just write that again. So I'm doing 2 minus 1/3. That's technically what I'm doing. That's a minus sign, I'm sorry. So 2 minus 1/3. And then I'm going to get that answer. And that's 5/3. Okay, now let's not forget, though, that I still have that other exponent on the outside of negative 1/2. So remember that when we have a power raised to another power, we multiply those exponents. Keep the base, and we multiply the exponents. So I'm going to keep the base, and I'm going to multiply 5/3 times negative 1/2. And again, you can do that in the calculator. 5/3 times negative 1/2. And you will get negative 5/6. Now remember, technically, when we're multiplying fractions, we multiply the two numerators together, so 5 times negative 1, which gives me this negative 5. And then we multiply the two denominators together, 3 times 2, and that's how I got 6. All right, so here we are. So we finally have a base with one exponent. Now remember, when that exponent is negative, we can make that exponent positive if we drop this down to, oops, let me undo that. If we drop this down to the denominator, so now I just made my exponent positive. Okay, then from there, I'm just going to do power over root. So my power is 5, and my root is 6. So I'm going to put the 6 right here, because that's my root. So that's going to put that right there, and my power will stay right here. And then if you look at that, we have choice 2. Okay, so with this one we have a couple of things going on. So I notice here that I have a power to a power, so I know that I can multiply those exponents. And here I'm going to do power over root, so I can get it out of that radical form. So let's start with the numerator first. So power to a power, right, we multiply the exponents. So what I really have then is b to the 4 over 1 times, or I should say, to the 2/3. Okay? And then down here, I'm going to take that out of radical form. So I'm going to do power over root. Okay, so remember when you're multiplying fractions, you multiply the two numerators together, which is going to give me 8, over the two denominators multiplied together, which is going to give me 3. So that's going to give me b to the 8/3 over b to the 5/4. Okay, so just like in number 5, now what I have is I have division with the same base. So remember, we're going to subtract the exponents. So I'm going to do 8/3 minus 5/4. And you can do that in your calculator. Okay, and that is going to give you b to the 17 over 12. And if we read the directions, it says write it as a single term with a rational exponent. There we go. Since the exponent is negative, I'm going to move that to the denominator to make it positive. So I'm going to start by keeping the 4, negative 4, and then moving that exponent down to the denominator, which makes the exponent now positive. Okay? All right. So then from there, I would say, well, let's try power over root. Well, I know that the power is going to be 7, and my root is a 2, so that's a square root, right? So that's the square root of x to the 7th. Now I still don't see that in any of my 4 answer choices, so I'm going to keep going until I find something that starts to look like it. And I say, well, wait a minute, x to the 7th underneath the square root. I could simplify that, couldn't I? And make that x to the 6th and x to the 1st, technically, right? And the reason why I'm doing that is because I know that this is a perfect square. Remember, any even power is a perfect square. And I just have to divide by 2. So this is going to give me negative 4 over x cubed times radical x. Okay, because I'm dividing that 6 by 2, and I got 3. Okay, now I know that I can't have a radical in the denominator of any fraction, so let's rationalize that. So I'm going to multiply the numerator and the denominator by radical x, because that will rationalize the denominator. In other words, it will get rid of the radical that's currently in the denominator. All right, I'm going to just continue this down here. So then that's going to give me negative 4 radical x in the numerator, right, because I'm multiplying these two. Now I'm going to multiply these two. Now what's radical x times radical x? Any radical times itself is just that thing without the radical sign. So that's going to be x cubed times another x, right? Which is really x to the fourth, isn't it? So negative 4 radical x over x to the fourth. Now look at this. This is choice 4. Now another way to do number 7 is, it is a multiple choice, so we could mathematically cheat. So look at what I did here. So I just picked any number, just not negative 1, 0, or 1, and I stored it in my calculator as x. Okay, any number, just not negative 1, 0, or 1. So I just picked 2, store as x. Okay, then I typed in the original equation, or I'm sorry, the original expression that was given, and this is what I get. So basically what the calculator is doing is putting in a negative 2 here. I'm sorry, putting in a 2 here, raising it to the negative 7/2 power, and then multiplying by negative 4. And that's what this gets. That's what the calculator gives you, okay? And then if you type in answer choice 4, okay, so look at answer choice 4 here, typed in. Look, I get the same thing. And by the way, this got cut off, but this is negative 7/2 up here, okay? You see that this answer and this answer are the same thing, so that's how I know that that's the answer choice. So for example, if you were to type in either choice 1, 2, or 3, exactly as you see it written, it's not going to be negative 0.3535, da 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 da. So you can cheat that way. All right, so this one asks you to find the roots of the equation in simplest a plus bi form. Whenever I see simplest a plus bi form, I know I'm always going to do the quadratic formula. So I'm going to start with x equals, now it's negative b, right? So it's going to be positive 3 plus or minus square root b squared. Well, b is negative 3, so negative 3 when I square that is positive 9, minus 4 times a, which is 4, times c, which is 6. And that whole right side of the equal sign is over 2 times a, 2 times 4. Okay, well you can plug what's underneath that radical into your calculator, and you are going to get the square root of negative 87. All right, so we have x equals 3 plus or minus the square root of negative 87 over 8. Okay, now just remember, you can't have a radical that has a negative underneath it. That's imaginary, right? So, and if you put 87 divided by x in your calculator, you'll see that you don't have any perfect squares. So all we're going to do then is, we always want that negative out from underneath that radical. So we're going to write I radical 87. The whole thing is over 8, right? Okay, so a plus bi form, remember we need to separate our answers. So we're going to write x equals 3 over 8 plus I radical 87 over 8. And then the other answer would be x equals 3 over 8 minus I radical 87 over 8. So here are your two imaginary roots. Now, also keep in mind, I know some of you will take this I and put it at the end here. That's totally fine. Same thing with this one. You put it at the end here. Just make sure it's not underneath the radical. Okay, so make sure that it clearly looks like it's not underneath that radical. So just like number 8, number 9 says simplest a plus bi form, so I know that I'm definitely going to be doing the quadratic formula. I want to, though, look at this, and I see that it's a fractional equation. So I know that I'm going to end up having to find a common denominator, right? So I'm just rewriting this so I have a little more space, and I'm going to get that negative 2 to have a denominator of 1. So let's look at it. I have a monomial x as my denominator. That's right here. And I have a binomial x minus 3. Remember, this x is different than this x because this x right here is attached to the minus 3. So this is a binomial, this is a monomial. And I mean, 1 is technically a denominator, but obviously 1 times anything is just that anything, so we kind of don't really focus on it too much. So I see that my first denominator is going to need an x, and so will the numerator, right? Because what you do to the denominator, you need to do to the numerator. Now, if I look at my second fraction, well, that needs an x minus 3. Numerator and denominator. So let's just stop for a second. So do you see this denominator here matches this denominator here, which is what we want. But I also want this one to match this one and this one as well. Okay, and that doesn't have anything, it's just got a 1. So this needs everything. So it needs an x and it needs an x minus 3. Same thing with the numerator. It needs an x and an x minus 3. So once you've gotten your common denominator and you've resituated those numerators, and it is an equation, because we have an equal sign, we can cross off the denominators, right? And now we're going to write 5x squared. Okay, now be careful here. Make sure that you are distributing that negative as well as the 4. So that would be minus 4x, and that will be plus 12. Okay, equals, same thing over here on the right. Distribute that negative as well. So that's going to be a negative 2x squared, and that will be plus 6x. All right, so now I look at this and I say, well, I've got a quadratic equation because my highest exponent is a 2. So I want to get everything to one side and set it equal to 0, because simplest a plus bi form tells me I have to do quadratic formula. And I can only do quadratic formula when my equation is set equal to 0. So I'm going to take everything on the right and I'm going to move it over to the left side, so that I can get this set equal to 0. All right, so I've got 7x squared minus 10x plus 12 equals 0. Now we can work with this. So I've got x equals negative b, which is going to be 10, plus or minus the square root of b squared. Well, negative 10 squared is 100, minus 4 times a, which is 7, and c, which is 12. And the whole thing is over 2 times a, which is 7. Okay, so if we plug that into our calculator, we're going to get the square root of negative 236. Now I'm going to put that in my calculator, in my y1, do 236 divided by x. That way I can find out what my perfect squares are. And my perfect square is a 4. And then the other factor would be 59. Okay, so x equals 10 plus or minus. Now, again, remember that what's underneath the radical is a negative, so we're going to have an I there. So I'm going to take this square root of 4, which is 2, and then that negative is going to be represented by an I, right? So 2I radical 59, and all of that is over 14. Okay, well, I see that I have factors here, a number that goes into 10, 2, and 14, right? Okay, so that would be a 2. So this will become a 5, this will become a 1, and this will become a 7. And don't forget, it says in simplest a plus bi form, so I'm going to want to split this up at the same time. All right, so let me do this nice and slow. So here we go. So I'm going to have x equals 5 plus, oops, I'm sorry, 5 over 7, sorry, 5 over 7 plus, and that's going to be I radical 59 over 7. So there's one solution. And then the other one will be x equals 5 over 7 minus I radical 59 over 7. Okay, and like I said in the last question, in number 8, you can take that I, if you so choose, and this I can go at the end of the radical. Just make sure it's not underneath the radical. When something is cubed, that means you write that quantity 3 times and multiply it. So I'm going to start with just multiplying these two right here. So I'm going to double distribute. Okay. So at first, I'm going to distribute the 1 through, and then after that, I'll distribute the negative 2i through. All right, so why don't we try that? So I'm going to end up with 1. Then I'm going to end up with minus 2i. Then minus 2i. Then plus 4i squared. All right, and I'm just going to bring down that last factor for now until I'm ready. So let's look at the left side of the left parentheses rather. Well, I know I squared is negative 1, so let's just do this. So I'm going to have 1 minus 4i, and then I squared is negative 1, so that's 4 times negative 1, which will make that minus 4, right? And then times 1 minus 2i. Just keep bringing that down for now. All right, last thing on the left parentheses, I can do 1 minus 4. So that's going to give me negative 3. And this would be minus 4i. And now I have 1 minus 2i brought down again. So now if you look at this, this is one binomial multiplied by another binomial, which is what I did in the very beginning, right? So I'm going to do the same exact thing as what I did in the very beginning. So I'm going to distribute. So I'm going to start by distributing my negative 3 through. How about we do that first, okay? And that's going to give me negative 3 plus 6i. And then after that, I'm going to distribute my negative 4i through. Okay. And that is going to give me minus 4i and then plus 8i squared. All right, so I have negative 3. These are like terms, right? So I'm going to add those, and that's going to give me plus 2i. And there's that I squared again. Okay, I squared is negative 1, so that's going to multiply with that 8, which will make that a minus 8. And then I'm going to combine my like terms, negative 3 and then negative 8, which is negative 11, plus 2i. Okay, so we want to know for part A and B and C what the remainder is when h of x is divided by a certain factor. Well, in part A, if h of x is divided by x plus 1, that would mean that x equals 1 would be the 0, correct? So then all I do is I go over to the graph, I find out where x is equal to 1, and I figure out what the y value is, because that will be the remainder. So I just follow this up, and I see that it's at 8, so then my answer would be 8. All right, we're going to do the same thing for part B. So part B, if the remainder, if they want the remainder when h of x is divided by x minus 1, then, oops, I totally made a mistake, didn't I, everybody? Didn't I? I made a mistake on part A. It says, what is the remainder when h of x is divided by x plus 1? So that means its 0 is x equals negative 1. That's totally my fault. So let's go back again. At negative 1, look, the y value is 0. So let's just go back here, and this will not be an 8. It will actually be 0. My fault. So now when we get to part B, if the factor is x minus 1, that means the 0 is x equals positive 1. And I'm just going to reiterate again, even though I know I just explained it. when x is equal to 1, go up to where that x value hits the graph, find the y value associated with it, and that will be your remainder. So my remainder for part B is 8. All right, let's look at part C. If we're divided by x, that means it's 0 is x equals 0. So let's find x equals 0, go up, find its y value, and that looks to me like that's a 6, correct? So that'll be your remainder, 6. For part D, it says, what is the relative maximum value? Remember that when they are asking for the value, what they really want is the y value. So make sure that you're giving the y value as your answer. So let's find the maximum, and we can see that the maximum is right here. Okay, so the x value is at x equals 1, but we follow it up to the y value, which would be a positive 8. So again, because they're asking for the value, our answer would just be an 8. Okay, now let's look at part E. So it says describe the end behavior of h of x. Now remember, end behavior has a set form. And if you look at this, this is the form that we have. So we always have, as x goes to negative infinity, what will our y value approach? And as x goes to positive infinity, what will our y value approach? Okay, so let's just look at it in a different way. So as x goes to negative infinity, that basically means look at the left side of your graph, and am I going up or am I going down? So the left side of my graph is right here, and do you notice that it's going up? So then that means the answer would be positive infinity. Okay, so now let's look at the next one. This one's really saying as x goes to infinity really means look at the right side of your graph. And what is the y value doing? Is it going up or down? So I'm going to look at the right side of my graph, and I notice the right side of my graph is going down. Okay, so we would represent going down as negative infinity. All right, part F wants you to write the equation of h of x. All right, so we know that any equation should have a constant for its leading coefficient. Now, if we look at the zeros, we have a 0 at x equals negative 3, at x equals negative 1, and at x equals 2. But when we write the equation, we want to write them as factors, so we're going to switch the signs of those zeros. So if x equals negative 3, then its factor would be x plus 3. And if x equals negative 1, then its factor would be x plus 1. And then lastly, if x equals 2, then its factor would be x minus 2. Then remember, to find c, what we usually do is we plug in a point that's on the graph. And the easiest one to pick would be the y-intercept. So we see here that the y-intercept is at 0, 6. So that's the point that I'm going to use. So I'm just going to write it over here. So I'm going to put in the point 0, 6. So 6 is my h of x, right? That's my y value, equals c. And everywhere I see an x, I'm going to plug in 0. So 0 plus 3 times 0 plus 1 times 0 minus 2. So I have 6 equals c times 3 times 1 times negative 2. So 6 equals c times negative 6, and let's divide out that negative 6. So I have c equals negative 1. Now, read the directions, because that's not what it's asking for. It's asking you to write an equation of h of x. So basically, I'm going to take these two things and combine them. So I'm going to have h of x equals, now I'm going to replace the c with negative 1 times x plus 3 times x plus 1 times x minus 2. And there is your equation for h of x. So to determine the zeros, we want to take this f of x equation and we want to set it equal to 0. Now remember, when we want zeros, we want our answers to be in the form of x equals and then some number. So I'm going to try to factor this thing and then solve. So I look and I see that I have a GCF of 2 and also of x squared. So let's take out the 2 and the x squared. That look like a 2. And I'm going to get x to the 4th minus 17 x squared plus 72 equals 0. Okay. So I have a trinomial, 3 terms here, right? And my lead coefficient of my x to the 4th is a 1, so I'm just going to do the AM method. So I'm going to figure out what adds to negative 17 that would multiply to a positive 72. So let me bring down that factor of 2x squared, and then I would say, well, since I have x to the 4th, right, that's going to break down to x squared and x squared. Okay, and so what multiplies to 72? Well, that would be a 9 and an 8, and that will give me 17, but I need negative 17, so both of those would have to be negative. Okay, and let's just double check. So if I add negative 9 and negative 8, I get negative 17. If I multiply negative 9 times negative 8, I do get positive 72. So I know that I'm good there. But I also notice that right here, I have dots. So I want to take that a step further and keep going with that. So I've got 2x squared, then I've got x minus 3, x plus 3. And I do not have dots because 8 is not a perfect square, so I'm just going to bring that down. Okay. All right. So those are my factors. But that's not what the question's asking. It's asking for the zeros. So this is where we're going to do our little t-chart. All right, so we're going to set each of these factors equal to 0. Now there's some cheater methods, you know, where you can just change the sign of some of these, but I'm just going to show it all. I think it'll be a little bit easier. Okay, so on the far left here, so I could divide everything by 2, right? Which is still going to give me 0, right? So I'm going to have x squared equals 0. And I can take the square root of both sides, plus or minus, but isn't the square root of 0 just 0? So there's one of our zeros. Over here, I can add 3 to both sides. So x would equal 3. There's another 0. Here, I can subtract 3 from both sides. So x equals negative 3. Oops, let's make that look like a negative. There we go. All right, this last one. Well, I can add 8 to both sides, right? So I get x squared equals 8. And then I know if I want to get rid of a square, I have to square root, right? So I'm going to square root this side, and I'm going to square root this side. Don't forget, though, we need a plus or minus. So that's really important. Don't forget that plus or minus. So then that's going to give me x equals plus or minus radical 8. Now radical 8 can break down. Remember, radical 8 is really 4 times 2, and 4 is a perfect square. So the square root of 4 is going to be 2, and then radical 2 does not break down. So let me just show you again. So this radical 4 became this 2. Okay, because the square root of 4 is 2, and then that 2 right there is right here. Okay, and so then we've got our last set of zeros. Okay, now remember, here we really have 2 zeros here. We have the positive 2 radical 2 and the negative 2 radical 2. Okay, so we have 1, 2, 3, 4, 5 zeros. Okay? All right, so for number 13a, they're telling you that x minus 8 is a factor. So if x minus 8 is a factor, then we know that it's going to divide in evenly, correct? Okay, so I'm actually going to just, I'm going to throw this all the way down here because I think it will just give me a little bit more room. So I have x minus 8, and I'm going to divide that into x cubed minus 7x squared minus 28x plus 160. Okay, now again, I know that it does factor because it says that it is a factor. I mean that it does divide in. So, and it's going to divide in evenly. So I should end up with a remainder of 0. So let's get started. So I know here that I'm going to have x squared, right? So then I'm going to take that x squared and I'm going to multiply by that x, and that'll give me x cubed. So that's going to give me x cubed. And then I'm going to take this x squared and I'm going to multiply it by that negative 8, right? And that's going to give me negative 8x squared. Okay. So now, don't forget that we want to change and circle, change and circle. All right, that is going to cross out our first terms, and we're going to be left with x squared here. And I'm going to drop down that minus 28x. Okay, then I'm going to do it again. So x, this x, times this x will give me x squared. Okay, so I'm going to have x squared here, and then I'm going to take this x times that negative 8, and that is going to give me negative 8x. All right, so now, again, we're going to have to change and circle, change and circle. So then our x squareds are going to cancel out, and then we're going to end up with negative 20x, and let's drop down the 160. Okay, one last time. So I'm going to have a minus 20 up here, and then when I multiply that through, I'm going to get negative 20x plus 160, and then when I do all my little changing and my circling, everything's going to cancel out, right? Because that's going to become a positive, this is going to become a negative, and those guys are gone. Okay? All right, so that's part of the answer for part A. Now let's look at the rest of the answer for part A, because part A says use the fact that x minus 8 is a factor of f to factor this polynomial. So we know x minus 8 is a factor, and then we just got that x squared plus x minus 20 is also a factor. However, that x squared plus x minus 20 can be factored again. So that's AM. So let me open up two sets of parentheses, and I want to figure out what multiplies to 20, negative 20, that would add to a positive 1. Well, that would be a plus 5, and that would be x minus 4. Okay, so again, use the fact that x minus 8 is a factor of f to factor this polynomial. So here is the factors, of f of x. All right, part B says find the x-intercepts for the graph of f. Well, if our factors are x minus 8, x plus 5, and x minus 4, that means that our zeros are x equals 8, x equals negative 5, and x equals 4, correct? Those are our zeros. Let me write that. So these are my zeros, which is not what the question is saying. The question is asking for x-intercepts. So remember, x-intercepts are written as an ordered pair, x comma y. So this would be 8 comma 0. The next one would be negative 5 comma 0. And the last one would be 4 comma 0. Those are your x-intercepts, always written as an ordered pair. So part C is asking you to determine when f of x is equal to 3. So what I did was I just took the f of x equation and I set it equal to 3. I could try to solve this algebraically, but I'm going to run into some problems. And the other thing I want you to notice is if you look at what I underlined, it does say to the nearest tenth. So we can actually put this in my calculator, your calculator. So what I'm going to suggest that you probably do is let's put this in the y1, and let's put this in the y2. Okay, and then basically what we're going to do is we're going to see where they intersect. Okay, so why don't you take a minute and get that in your calculator, the f of x part into your y1 and 3 into your y2. Okay, so now when I did that, I hit zoom 6, and this is kind of what I got. So let me just kind of explain what this is, so hopefully it'll make it a little bit easier for you to see. Okay, so first of all, right here, that's our y-axis, right? Okay, and along here, this is our x-axis. Okay, so I'm just going to change the color so you can see this a little bit better. So basically, our picture starts like this, and it goes up high, and then it comes down, and then it goes down low, and then it comes back up again. All right, bad picture, but you kind of get the idea. All right, and then here horizontally is my y equals 3. Do you see that? So basically what we want to see is where the function, that's in blue here, hits y equals 3. So we're looking for this intersection point, this one, and this one. Okay, so you're going to do second calc intersect. And remember, when you do second calc intersect, it's going to bring up a cursor. And you want the cursor to be somewhere down here. Let's say I was looking for this intersection point. I want the cursor to be somewhere down here. Okay, so I'm going to repeat myself again. So you're going to hit second calc or second trace and go to intersect. Then get your cursor over here, hit enter. It's going to bump the cursor up to around here. You want it to be off to the right a little bit, like maybe somewhere around here. Hit enter twice. And when you do that, you're going to end up getting x equals, now rounded to the nearest tenth this is, you should have gotten x equals negative 4.9742, but to the nearest tenth, that's going to be negative 5.0. All right. So let's look at the next one. So now what we're looking for is we're looking for this intersection point. So we have to do it again. So second calc or second trace, hit intersect. Now you want your cursor to be somewhere in this general region here. Once you get it there, hit enter, and it's going to bump you down to this line again. You want to be to the right of this intersection point. So just a little bit to the right. Don't go too far over because it'll give you this intersection point by accident. So let's say maybe right around here. Hit enter twice. And we're going to round to the nearest tenth now because that's what the directions tell us we should do. So we're going to get x equals 3.9. And we do it one more time for the last intersection point, which would be right over here. So second calc or second trace, intersect, put your cursor somewhere down here, hit enter. It's going to bump you up to this line and come off to the right somewhere here and hit enter twice. Okay, and then again we're rounding to the nearest tenth and I have 8.1. So right here, these are the answers where the function is equal to 3. So simplifying is going to require that we do some factoring and canceling. So I'm going to start by taking that numerator, and I see that there's a GCF of 4, so I'm going to take that 4 out, and then I have 49 minus 4x to the 4th. Okay, I'm going to come back to that. Let's look at the denominator. I see it too has a GCF. It has a GCF of 2. So let me take that out. And I'm going to have 2x to the 4th plus 5x squared minus 7. Okay, so now let's look back at that numerator. So I took a 4 out, and I do see that I have dots. So I'm going to open up 2 sets of parentheses. And I'm going to have 7 in the beginning of each of them, plus or minus, and then the square root of 4 is 2, and the square root of x to the 4th is x squared. Okay, and there isn't anything else I can do with that, so I'm going to leave that. All right, now, let's look at what we have in the denominator. So we took out a 2, right? Well, I have rainbow here, so I want to figure out what multiplies to negative 14 and would add to 5. Okay, so remember we bring down the first term and we bring down the last term. All right, so what multiplies to negative 14 and adds to 5? That would be a negative 2x squared and a plus 7x squared. Now remember I'm writing x squared because we look at whatever the variable is of that middle term, and that's what we write next to each of those numbers. Okay, so don't forget that. Okay, so then I'm going to group these guys, and I'm going to group these guys. That's parentheses, sorry about that. Okay, so let's just take a little detour here. So if I group those, I'm going to get 2x squared, and that's going to leave me with x squared minus 1. And then if I group this next group here, I'm going to take out a 7, and that's going to leave me with x squared minus 1. So I have 2x squared plus 7, and x squared minus 1, remember that's dots, so that's x minus 1 and x plus 1. Okay? All right, so let's bring this down, and here's my numerator. Let me just rewrite it, 7 minus 2x squared. And 7 plus 2x squared. Okay, and then the denominator. Well, I've got 2x squared plus 7, and then I've got x minus 1, and I've got x plus 1. Okay, so let's see what like terms we have in the numerator and the denominator that we can cancel. Well, 2x squared plus 7, and that's really 2x squared plus 7. Okay, and I'm just looking to see if I have anything else. I did forget to bring this 2 down, so that 2 should, see here. Okay, so this is going to cross out, and that's going to become a 2. So the final answer is going to be, in the numerator we have a factor of 2, as well as a factor of 7 minus 2x squared. And then in the denominator, we have a factor of x minus 1, as well as the factor of x plus 1. There you go. This question asks you to algebraically prove. So remember when we algebraically prove something, that means one side of the equation, whether it be this left side or this right side, we have to leave alone and don't touch it. Because I see that we have an operation of subtraction here, this is the side that I'm going to manipulate or change, and this is the side that I'm going to leave the same. Don't ever touch this, and don't cross out denominators. We cross out denominators when we have an equation, which we do, but when the directions say solve for x, or just solve, which this does not say, so no crossing out of denominators. Okay, so if I look on the left side here, I have two fractions and they're being subtracted, but I don't have a common denominator. So let's start with figuring that out. So I know that this first fraction is going to have to get multiplied by a factor of x plus 1. And the second fraction is going to get multiplied by a factor of x. And when I do that, you can see that I have a common denominator now. Okay. So my new numerator of the first fraction is going to be x plus 1. And then I'm going to bring down this minus sign right here. Okay, so I'm going to write minus. And then I'm going to bring down the second numerator, which is x. Okay, now again, they have a common denominator. So I'm going to leave that as x times x plus 1. Remember, I'm not going to be canceling out the denominators because the directions say algebraically prove. It does not say solve. Solve is when you would cross out the denominators. We're not going to do that. So I'm going to just keep bringing down. Remember, we just keep bringing down this right-hand side. We never want to touch it. But on the left-hand side, I can simplify my numerators, and I see that I'm going to be left with 1 over x, parentheses, x plus 1. And over here I have 1 over x times 1 over x plus 1. Okay, so let's just kind of take note of a couple of things. Do you see that really here 1 times 1 is 1, which is what I've got here? Look at the denominators. They really are the same thing, right? But this is 1 fraction, and this is 2. So remember, this is the side, though, that we're not manipulating, so we're not changing. So we've got to change this side so it matches this. Well, can't I split this up? So watch what I mean by that if you're not following me. Isn't 1 over x times 1 over x plus 1 the same thing as this? Because 1 times 1 is 1, and then this x here times this x plus 1 is really x times x plus 1. So what I did was I just split this fraction up into 2 separate fractions whose product, when I multiply, gives me this. And the reason why we're doing that, obviously, is because then that matches the right side of the equation, which is our goal, because algebraically proving means let's try to get the left side to match the right side. Okay? And so, therefore, we have proven it.